So as busy scientists, I'm sure that you've all picked up a lunch in one of these boxes at some point. Now, when I was a kid, the bottom of these lunch boxes used to be made from a vacuum-formed plastic most of the time. And now, most of the time, you see these made out of paperboard. This I find very inspiring because it's a great example of paper being used for something instead of plastics. However, we usually see that the lids of these are still made out of plastic. And the reason for that is that paper is not transparent, and we would like to see the food that we are buying. But wouldn't it be great if we could create a lid that's transparent and that's made from cellulose and that can also be recycled along with the bottom of this box? So with cellulose nanofibrils, we can do something like this. Cellulose nanofibrils we extract from wood, and these nanoscopic building blocks are small enough that we form transparent materials. However, of course, these nanopapers come with a few challenges as compared to traditional plastics. So they are sensitive to moisture, they can be quite brittle, and it's difficult to vacuum form them into a lid, as you saw on the previous slide. So our research focuses on these tailored additives that you see here, called nanolatexes. So we synthesize block copolymers that self-assemble into these nanoscopic, colloidally stable particles. So we can, with the red block of the polymer, control the size and the softness of the particles. But what's more interesting for cellulose is that we can control the blue block. So this forms the surface of the particle, and it controls how the particles or nanolatex additive interacts with cellulose. So an example of this is if you take cationic polymer, so cationic surface of our particles, we will have very strong interaction between the particle and the cellulose. So we can start by doing a surface tailoring, where we are hydrophobizing the surface. We can also do a nanostructural tailoring inside the material, from where we can make the material more or less formable. And in this vision is also that we will be able to, at the end of life, separate the nanocellulose from the nanolatex component so that we can do a recycling, separation, and then form new nanostructured materials at the end. So with that vision, I hope that I've convinced you that we will be able to make a transparent lid for your next lunchbox. My name is Jerlhagen, and please visit my poster after for more discussion.